ownerships refers to who has the task of handling the deletion of the pointer. After the pointers are created, you will see that we have one example. They are used like row pointers. For share pointers and unique pointers, you can dereference them. Not for weak pointers. You can dereference them, and it comes with some methods which can be used to do various tasks. So smart pointers internally contain a C pointer at the moment, a C pointer, and some other tools we will see in a second. But around these row pointers we have some methods which work behind the scenes when objects go out of scope. So, address the issue of surrounding object ownership. Object ownership is a problem to be solved, and this problem is solved by smart pointers. As I mentioned, ownerships refer to who is responsible for releasing the memory back to the system. We haven't worked with a lot of data members or containers containing objects of pointer types, but in a real production, they use vectors of pointers, and the size of the vector can be 10,000, 11,000. If you think of how many web pages are there, million of objects, million of web pages, and sometimes programs have to deal with large amount of data. C++ is used for databases implementation, and nowadays databases tend to be very large. So a pointer may be copied many times, and then we end up with 10 pointers pointing to the same object. And if one pointer goes out of scope and releases a memory, the other 9 are in bad shape. So here is the simplest situation we can think of. It's the simplest to be aware. We have a container which has only 3 data members, which are pointers, and another container which has only 3 elements, and they are pointers pointing to the same object. Right. So these objects can be, for example, student objects, and here we have a list of IDs. Each student has an ID, so we have pointers here, and here we have courses, and the course container keeps track of these students which are enrolled in that course via pointers. Now, the thing is, if one of the objects goes out of scope, and if it releases a memory here, this object is in bad shape. We don't know in large programs if all these objects go out of scope first, and then this will have the task to release a memory, but this shouldn't release anything. Or maybe this goes out of scope first, and then this has to release a memory. Or only parts of this goes first out of scope, and then this goes out of scope, and so on. So there are a lot of combinations, and you can't provide a solution for each one. Just for this simple case, who is responsible to delete the object at which it points? What should happen when A or B is deleted? determine if the objects should be deleted, what is the order. In many cases, the order is not predictable. It depends on events, and those events happened in different order. So this memory ownership is a very difficult problem, and you can imagine that it's so difficult that we, people with a lot of experience, got it wrong. They are, as I mentioned, the previous smart, it was just one class called smart pointer, and now it's deprecated and it's out of use because it had mistakes. So share pointers are part of smart pointers which try to solve the problem where we have more pointers pointing to one object. All the smart pointers are implemented with class templates, and they all have somewhere a row pointer, which can be dereferenced once again, with one exception, the week pointer. Now, the handling, deleting dynamic memory is placed in the destructor of the smart pointers. So, if you use this group, you don't have to deal with deleting the memory. Destructors are called automatically for you. Remember, when the objects go out of scope, destructors are called automatically. And you will see that for these pointers we use new to construct them, but we never use delete on them because the deletion is done by the destructor. Anyway, the first group, share pointer, this is a syntax, remember. In order to use them, you have to include memory header file. And we have here a simple representation to let you know what goes behind the scenes. Assume that we have 3 pointers which have to point to a single object. They share ownership of this. This is called managed object. You have to know that behind the scene there is another object called manager object. As soon as you create the first share pointer, the system creates the manager object, and then this manager object points to the object you use for initialization with new. This manager object has the role to keep track of how many share pointers, and you will see a little bit more later, how many share pointers points here. So assume that we create this first share pointer, the manager is created and points to this object which is passed with new to this share pointer. When the next share pointer is created, and the rule is this has to be created from this, otherwise we are in trouble, because it is meant to point to the same object. What happened is this share pointer increases the counter, reference counter in the manager object to 2, and nothing happens because this pointer is there. But if we dereference this, we get access via manager object to the object to which it points. Assume that we have the third share pointer which is created from this or from this, then the reference count is incremented to 3, and they all now point to the same object, But if one object goes out of scope, right, this share pointer decreases to 2. When the next one goes out of scope, this manager object data member, which keeps track of current share pointer pointing, decreases to 1. And when this last one goes out of scope, the pointer, the reference count goes to 0. When the reference count goes to 0, the object is released to the system. Now from here, you can see that they are safe to use because via this manager object, the object to which it points returns to the system, and we don't have any problem with dangling pointers and memory leak. But because we work through the manager object, there is a slight overhead compared to the row pointers in C language, a slight overhead, which is not big, but it's still there. And the price for this overhead is considered to be small enough in order to avoid common errors. Once again, keep in mind that here we have 3 pointers, but normally this works for 10,000 pointers, which is a little bit of an issue. Right, so I explain what happens, and destroy or reassign whenever you can reassign share pointers to point to another object, then that reference count is decreased, of course. So when share count of the manager object reaches 0, only then this is returned to the memory. So with this approach, it doesn't matter which pointer or container goes out of scope. Doesn't matter, because with this we have for each object the share pointer count 2, and when the share point count reference count goes to 0, only then the object goes out of scope. So it doesn't matter the order of returning from the function and this container going out of scope. Right. But things are never simple. Sometimes there is a cyclic referencing. In this example, we have a single container which has 3 share pointers pointing to this memory location. And there are pointers between these objects which are not accessed from outside the circle, right? So we have share pointers who points here, point here, point here. And even when this pointer goes out of scope, these share pointers keep these 3 objects alive, but they are not available from outside in any way. They keep alive themselves in an artificial way. So what we would like is, when this object goes out of scope, these 3 objects to return to the system, even if somehow they connect each one with each other. Right. If we have share pointers, they as I said before, keeping themselves alive, even if you can't have a handle from outside world to access them. When container A is deleted, the objects are still alive, causing a memory leak. Yeah, these are destroyed, and now these share pointers don't have any handles to access them and delete them. The solution provided by the committee was to introduce what is called weak pointers. They are not owners of the memory, they are observers. They are quite limited in what they can do, you will see. They have no responsibility to delete memory because they don't own anything. They just can tell you if an object is there or not. This is a syntax, and in order to allow for these weak pointers to go work properly, the setup is the following. When a share pointer is first constructed, that manager object is created, and it comes with various other features, but two data members, one which keeps track of share pointers and one which keeps track of weak pointers. Initially, weak pointers is 0. Share pointer is set to 1, and the managed object is stored in one location. Then every time when a share pointer is constructed from SP1, the counter is incremented, so we end up with 3 here. For when we design the first weak pointer from a share pointer, you can't say construct with new a weak pointer. This is not available. A weak pointer can be constructed only from a share pointer. Then the weak counter starts incrementing. Every time when a share pointer goes out of scope or is reassigned, this is reset. And when this number for share pointers goes to 0, this object is returned to the system. When the weak counter goes to 0, this manager is destroyed. Weak pointers go out of scope themselves. Sometimes they can be reassigned and work. So as you can see, working with memory in a safe way, it's a very complicated thing. For simple cases, if you have just 1 or 2 pointers, that's fine. But if you have many pointers, then things become very complicated. So I mentioned this combination between share and weak counters give you some rules which I mentioned. Share count of the manager is 0. The object is returned to the system. When share and weak count of the manager reaches 0, the manager is deleted, or everything goes away. Right. So, for that situation we have seen, we have the share pointers, elements of container A, and when we create linked pointers between the object, the weak pointers are constructed. This weak pointer is created from this share pointer, so it's fine. Now, if you look a little bit at the syntax, I said for using this code, you have to include memory. Notice you can have share pointers designed from primitive types or from your user types, from strings or from student or from courses. And the way to do it is called the constructor. This is a constructor of the share pointer type with new. We are constructed a share pointer, new int, and then we can dereference sp1 and store a value there. Dereference sp1, store 5. At that moment, we have share pointer count 1. Notice how to construct another share pointer to the same object using copy constructor. We construct sp2 from sp1, and in that, with this syntax, this is good. This is not the assignment operator. I remind you, this introduces a new variable in the scope. So this is copy constructor. This is equivalent with this notation, sp2 brackets, sp1. And at this moment, we have two share pointers point to a single object. And then we can dereference and display whatever. So from now on, the use of the share pointer is similar partially to the row pointers, but it comes with many functions we are not touching because it's a big topic. When they go out of scope, notice the dynamic memory will be returned for the objects to which they point, because the destructor for share pointers is called. You don't have to do anything. So it's a case where you use new, but you don't use delete here. The destructor is called automatically and does everything which is required. So from this point of view, it's much easier to use. On the other hand, the syntax is not so easy, and there is a lot of learning how to use them properly. For example, if you have some remembering that we defined a complex type a while ago, a complex which takes two double values and perform addition, assignment, and stuff like that. We can use share pointer with our defined type, like here, right? You have to specify what is the type of the element to which it points. Choose a name, use new, and call the type you are using, like you call for native types. And then in that complex type, we had a print method. You use the pointer notation to invoke the print to display whatever was put in the print method. At the end, we are done. The destructor will handle the allocation. So as you can see for this, it's something like we have garbage collector behind the scene for these smart pointers. The weak pointer does not own the object, cannot be used to access the manage object as the object to which the share pointer was pointing might not exist. They can be used to determine if the object still exists. That's why they are called observers. And they work only via share pointer. Restrictions. So these pointers should be used with objects that are allocated allocating using new and delete from C, for example. You can't work with pointers of that type. P is a pointer to int, and P takes the address of variable A, which was declared previously. This is defined on stack. So this refers to that fact. Should never be used to point to objects that are allocated on the stack. We have an integer A variable set to 7, and then I say pointer P to int equal address of A. I am not using new here, right? I can't use this P to construct a smart pointer from it. I can't. Because the destructor, when called, will try to release a memory which is allocated for A variable. And things are horrible. As I said, nothing is 100% foolproof. The code you use has to be designed in such a way that only one manager object exists for the managed object. And we have an example where this condition is not fulfilled. And if we have two manager objects for managing the same object, when one manager object gets its reference count to 0, the object is released, and the second manager object is in bad shape. Okay. So, in order to abide to this rule, we always have to make sure that after we create one share pointer, every other share pointer or weak pointer we create is created from that share pointer if we want to use the same object. If we work with different objects, that's a different story. Yes?
Could you give an example of when or why you'd use a weak pointer instead of another shared pointer?
I think that I have somewhere, but we will see. Oh, this is not a weak pointer. We will. I don't know if I have one here, but I will think about it. So, in this example, we have code which violates the rule of having a single object manager for the managed object. Why? As you can see here, we have a simple row pointer here. P is constructed like a pointer to a complex. This is C-type pointer. And then we construct the first share pointer from this P. And at that moment, we have a manager object which points to whatever object we had there. And then if we construct another share pointer from P, we end up with a second manager object. And both point to this object. So when this goes out of scope, this will be in bad shape because the memory was returned when this was out of scope. Okay? The solution is SP2 should be constructed from SP1 here. SP1. Because we want to have these share pointers linked to a single object. Right, another rule is use only share pointer or mixed or row pointers. Do not mix them, because if you mix them, you can end up with a situation like this. If we wouldn't have this object, we couldn't get, probably, if we try hard enough, we might get some other problems. All right, we will look for weak pointer in a second. abstract data type here means ADT, a type which comes with memory allocation and operators. It's not an abstract class, be aware. Abstract data types is a type which comes with its own operations, and in order to use them, you have to know the operations provided. It does automatic memory management and bounds check is good. You can design it to work with an individual object or an array of objects, but this is already complicated. I mentioned briefly that languages supporting automatic garbage collection, C# and Java, do not need smart pointers because this ownership is handled by the language. We will look briefly at this CVP reference and see what a unique pointer is. It's a pointer which owns a single pointer which owns an object, and no other pointer can own that object. So it's a one-to-one correspondence between the pointer and the object it owns. If you look at the reference, it's a templated class. This is a type of the element to which it points. As you can see, there are some deleting types, which are not something we will talk about. And with this, you can construct a unique pointer pointing to a single element, and here you can construct a unique pointer pointing to an array of elements. And this happens for everything in terms of pointers. We are talking about, be aware, defined in header memory. As I mentioned before, they all defined there. This owns and handles another object. Right. So the memory is disposed using the associate delimiter. These are things we are not going to get into details. So it does the allocation based on some tools it has, and the managed unique pointer object is assigned another pointer via assign operator or reset. So at any moment, a given object which is pointed by a unique pointer to has only that unique pointer looking at it. You can't copy the unique pointer. The copy constructor is deleted. You can have delete in a class starting with C++11 to prevent copy constructor to act. There is a move constructor which acts. Move constructor when the unique pointer is passed to a function. So copy constructor and copy assignment are deleted for this type. You know that any type comes with a copy assignment and the copy constructor and the default constructor. Now, the way to deal with this situation, delete operator is used on this copy constructor and copy assignment. As you can see, move constructible and move assignable. Yes, these are move constructor and move assignment are defined, but copy constructor and copy assignment are disallowed. So it comes with various operator, but the way to work with it is look at main. You can either call the constructor like we have seen for share pointer, or call make unique and pass a type here. And this make unique returns a make unique pointer, unique pointer. So auto here will be a unique pointer of D, whatever D was there. And after that, this can be used, P2 can be used like any other pointer. As you can see, to design another unique pointer from P, we have to use some function to move the ownership. Move the ownership of P to this new pointer. And after that, P owns nothing, as you can see, and Q owns everything which was in P. It has a bar method, but it doesn't matter here. And you can have vectors of unique pointers. Things can be very complex. Right. And the syntax can be quite complex, as you can see. But apparently there are some folks I have seen, companies using C++ extensively move to this pointer. So if you will have a life in working with C++, probably you will have to go into deeper reading of these smart pointers. But it's still something where many changes occur to improve the efficiency. Now, after this, I haven't got unique weak pointer, but I will try for next time to get some examples with weak pointer to see how they are used. After this, you might say, when should we use a unique pointer as compared to share pointer? A share pointer does everything which a unique pointer does. So why would we use a unique pointer and not use a share pointer? There are two reasons. One is a share pointer comes with overhead. I mentioned manager object is everything performed through the manager object in share pointers. A unique pointer has no overhead. It's almost as efficient as a row pointer. Everything is very clear and simple in terms of code working behind. This is one reason, and another reason is they come with different set of methods. You will see unique pointer has 3 or 4 member functions, while share pointers, because it has to deal with manager object and other things, comes with a lot of other features. You can construct a weak pointer from a share pointer, but never from a unique pointer. So, yep, this is all we had to do. To have a brief encounter into a brief view of this notion. Hopefully, it shows that things are very complicated. We want to use dynamic memory. We haven't worked with large programs, but when this happens, things are complicated. So, any questions besides some example with weak pointer? I will prepare some won't use this for tutorial. You will have one or two. I don't know, is the tutorial up? Not yet. Hopefully today will be up, because tomorrow is a tutorial. Yeah. Anyway, solutions will be good, so we'll see what's going on and what is expected in terms of this. For the final exam, you won't have code to write about pointers, smart pointers. You don't. Whatever was covered in the lecture notes should be in general understood, like object managed, manager object, which comes with those reference count I have talked about, stuff like that. Yeah. So this will come under true or false question. If something is true or false, but you won't have code writing. This is because I haven't checked. Okay. Thank you very much. See you next week. So tutorial will be on tomorrow normal time. And we start Java, as I mentioned before. Okay. You have to download your GDK if you haven't done it. Right, so I will tell you.
他明天的 live 上午就去了，也没太大，我记得我也没进去，反正都来过几次，然后之后
You have downloaded it Java introduction, you see, this will be the lecture which will be visible. And here you have Java Development Kit, GDK8. You have to go to this link and download GDK